Welcome to our lesson on matrix multiplication. In this lesson, we shall understand how matrices are multiplied, why compatibility is important, and why matrix multiplication is different from ordinary multiplication. By the end of this lesson, you will be able to multiply matrices, determine compatibility, and understand why matrix multiplication is not commutative. Consider a row matrix multiplied by a column matrix. Let us discover how multiplication works. To multiply matrices, we take a row and multiply it with a column. Multiply corresponding entries, then add the products. 2 times 4 plus 3 times 5 gives 23. Notice that the result is a 1 by 1 matrix. Observe the orders carefully. The first matrix has order 2 by 3, the second matrix has order 3 by 4. The inside numbers match, therefore multiplication is possible. The outside numbers give the order of the product, therefore the answer will be a 2 by 4 matrix. Let us reverse the order. Notice that we no longer obtain the answer 23. We obtain a 2 by 2 matrix. The answer is completely different. This shows one of the most important facts: matrix multiplication is generally not commutative. Remember these 3 important ideas. Matrix multiplication means row multiplied by column, compatibility is essential, and AB need not equal BA. In this lesson, we learnt the meaning of matrix multiplication. We also learnt compatibility and discovered that matrix multiplication is not commutative. Let us now generalize the compatibility rule. The number of columns of the first matrix must equal the number of rows of the second matrix. The inside numbers match, therefore multiplication is possible. The order of the answer comes from the outside numbers. Therefore the product will be a 2 by 4 matrix. Scalar multiplication is very simple. Multiply every element by the given number. Each element is multiplied by 3. To obtain each element of the answer, we multiply a row by a column. Let us find the first entry, first row multiplied by first column. 1 times 5 plus 2 times 7 gives 19. Repeating the process for every row and column pair gives the complete answer. Pause the video and try this question yourself. Check your answer carefully. Let us summarize what we have learnt. Matrix multiplication requires compatibility. The order of the answer comes from the outside numbers. Scalar multiplication affects every element, and every entry of a matrix product comes from row multiplied by column. Consider a 2 by 3 matrix and a 3 by 1 matrix. The inside numbers match, therefore AB exists. But the inside numbers do not match, therefore BA is not possible. Both products exist, however the answers have different orders. Try these examples yourself. Determine whether multiplication is possible. If it is possible, find the order of the resulting matrix. Pause the video if required. Let us calculate AB. Now calculate BA. Therefore, matrix multiplication is generally not commutative. Consider these two matrices. Do you think a B will equal BA? Pause the video and check. In this case, the two products are equal, therefore matrix multiplication can sometimes be commutative. Here is another example. Pause the video and verify that a B equals BA. So in addition to the diagonal matrix example, any matrix commutes with itself, any matrix commutes with the identity matrix. These are some important situations where matrix multiplication can be commutative. This is the identity matrix. It behaves like the number 1. Multiplying by the identity matrix leaves a matrix unchanged. Students often assume that algebraic identities work for matrices. Since AB and BA are usually different, we cannot combine them. Let us summarize what we have learnt. Matrix multiplication is based on the row multiplied by column principle. Multiplication is possible only when the inside numbers match. The outside numbers determine the order of the resulting matrix. Unlike ordinary numbers, matrix multiplication is generally not commutative. The identity matrix behaves like the number 1. Finally, algebraic identities must be used carefully because a B and B are usually different. In our next lesson, we shall solve examination-style questions involving matrix multiplication.